Hello everyone, welcome to my YouTube channel Data Partnership. So this video is continuation of my groundwater series. Uh, Today I'm going to show you how to analyze or how to clean up the post-monsoon data. Yeah, up to now I have mainly worked on the pre-monsoon data. So what I have done is I have downloaded. I'm just explaining what I have done. It's a summary, you can say. I have downloaded those data from CGWB website. So it was in PDF format. So I have downloaded pre-monsoon, monsoon, and post-monsoon and winter means January. So the pre-monsoon season I have downloaded three files 1994 to 2024 like this, right? So I have converted all these three files into Excel or CSV, then concatenated, means joined those three files and created one single CSV file. And there was problem of in the file. Basically, what was the problem? I'm just showing you. Problem was that you can see the state column. It means the latitude, longitude, and our value is correct, no issue. Even these are also correct. But what happened is that, like in state, names were incorrect. Means some part of the state are coming into the district or in the block or village, and so I have corrected that also by using one code. I have shared that in my previous video. I am sharing this link in the description box, but here also I have done. So now this is today I am going to do the post monsoon. The post monsoon we have only is very straightforward, only one file. It is similar 1994 to 2023 in one PDF only. So this is I have done, right. So I what I did is the CSV I have created from the PDF by using code that I have already shown to you earlier. The code was this, right. So based, I have used PDF Plumber, Ray, and Pandas. So I have created that is also I have created one video. I am sharing that link also. So now I have this post-monsoon CSV. So we have loaded that, and then you can see the same format like earlier. So these are the columns, and these are the state like that. The issue which I have just explained. So now what I did is based on the pattern, means we are state mapping. So we have based on that we define a function, and now we have the clean states. The value of states are now coming in order, right? What we want. So then we have exported that same file into the this post monsoon version 1.csv. So now you can see post monsoon version 1, the same file. I'm just not running the things, right, otherwise it will take time, or maybe I can do that, right. So run, run, right, and run, you can see, and you can see here, right. And this post monsoon version, so it is open, so it may create problem. So now we have this file. It's a huge file, right. So now now we will work on that. So before going ahead, so basically what we are doing is we have longitude, and DTWL. Those should be in the numeric form, right? This is the one is first step. Otherwise, sometimes it is in text format, and sometimes by doing analysis it creates problem. So that's why I'm just defining that these are in the numeric types. So because you need to take care of that in your other data also. So then we have pass date if available, because many have CGWB data have date or date pass. So just for the safe and I am doing that. I did in previous videos also. So you just copy paste this from here and you can check. So now we have one. We are creating one more. Means we are adding one column here, right? Yeah. So, yes, what I have done here is that this post monsoon version 1, I have created one data frame called DF1, right? So we have done the numeric and this date related thing there. So now I am adding one more column here, that year, right? So because then you can see DF1 dot ahead, you can see, right? So now you can see here we have one called one column called year, right? So now first one for what we will do is overall summary. So basically what we will DTWL stat TF means which column is this water level, right? Groundwater level. So basically this is the means how much entries. These are the counts, mean values, this seven standard deviation minimum, and these are the statistical parameters, right? So now this stat also you can save into CSV or right. So so now if we want that state level means state level uh, summary. So how to do that? This is about the whole data set now based on the DTW. Now somebody wants to know the what is the status of state level. So what we have done is the DF1 group by the state column. Right? We have defined the state column here, state clean, this one. Right. So after doing this, then we have group by the state column, and what we need here is DTW mainly, and what should be aggregate count and these statistical parameters and all. So you can see we have these values, right? For the all the state, you can export that also, state dot summary like this, and you can get there. And most why it is happening. Okay, so you can just delete this one. Yeah. So you can see post monsoon summary also you can download it here. Post monsoon. Yeah. Means everything whatever you are doing you can export that. So now you have all the data. So you can use in your reports and all. It all depends on the what you are. So year wise, suppose you want to know the year wise details means what is the mean value of DTW. So you can see. So this is the code you can write here. It's very simple. If df on here is no DNA, then dot any means here you can just group by year and DTWL mean, or if you mean standard deviation, whatever you need, you can define here. So accordingly, you have this all the data and you can export that also into the CSV here, right? So based on that, then you can, if you want to plot this data, then you can do like this. uh, it will take some time, right? Or otherwise if you want to plot year wise, then you can see it's a very simple thing, right? I have already done it many times. So you can see we have okay, this is the scatter plot, and if you want to do the year wise plot, then you can see the post monsoon. So how what is the you can see here there is one in 2005 there is one more than basically it's the mean value, so more than 14. So it means then sometime such values is like uh, uh, outlier. So what we can do is then we can see the 2000, it should be the 2004, I think. Yeah, 2000, 2000, 2003, 2000, 2001, 2002, 2003, and 2004. It's a 2004 data. So sometime we need to check the 2004. Like let's see, this is the best source to see the you know to see the things like what is the issue in the 2004. So we can check that. So you can find out whether what are the problem. So you can see here. So it is one of the method to check the outline. You can do that in Excel also, but you can see, right, 2004. So you can see in 2004, you can see the value, right? You see here in 2004, there may be some big values. So this is a simple way, like this you can see here, 147 mean is coming like that. So you can see how in which month it is, right? So that you can check those values, those big values, right? Why it is coming, so that you can check, or there is maybe some conservation measure has been done by government. So you can see this is the April month. So in the April month in 2004, means it is like this, right? Is the post monsoon data. So it should not be the post monsoon, right? It's the 5 May. It's basically it should be the pre monsoon, but why it is happening? So it means they so you can Of course, this is the data I have taken from that site, website, so you can see here, right? So it's a 30th, means May. It's a May data, but we are talking about the post. Okay, sorry, it's a pre-monsoon data. I'm checking, right? So we have to check the post-monsoon data. Sorry. So post-monsoon data is this one. Maybe this is the problem in the post-monsoon data. We need to check what is coming, right? Yeah. So post-monsoon data we have to in the 2000. Okay, 2004. So maybe I have not. So what we have to do is, so basically similarly you can check there, right? So from here I have to export this file from here, right? So DF1 to CSV post data.csv. Yeah. So we can check there, right? It may take some time. So basically what I'm saying that, so plotting this kind of plotting help us to know the outliers, right? So that's the objective. What objective is here to show how to, you can see. So now you can check very easily here, or maybe by through some code you can do that. I will do, then I can check in 2004, right? So you can check what happened actually in 2004. So now if you see in the 2004, of course it's the mean value, but just this is just, we can check what happening basically, that what are the bigger value, right? So you can see here. So it's in the thousands, right? So it's which month it is? In November month. So it means there are some problem. This it cannot be a value like that. So that's why these values are coming like this, right? So it always helpful to 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 means basically it is always a good habit to check the data by plotting. So you can do that is by easily doing by the Python. If you have a readily available code, then you can check in a minute, right? So this is what I wanted to show you in this video. Next video I will come with more details, right? Thank you.